So, let's go. Right now, 4 astronauts are traveling 250,000 miles from Earth in a spacecraft whose heat shield already cracked once. NASA flew it anyway. And that's not even the most alarming thing about this mission. Here are 10 things NASA doesn't want you to know about Artemis II. Number 1. The heat shield that already failed. The most dangerous 5 minutes of this mission aren't launch. They're the last 5 minutes. When Orion hits Earth's atmosphere at 25,000 miles per hour on the way home, the bottom of the capsule has to survive temperatures of 5,000 degrees Fahrenheit. That's roughly half the temperature of the surface of the sun. The only thing standing between 4 humans and that heat is a layer of material called AV coat, applied in about 180 large blocks across a 16.5-foot disc bolted to the bottom of the spacecraft. You know what those blocks did on the last test flight? They broke off, in chunks. In December 2022, when the uncrewed Artemis I returned from the moon, engineers found more than 100 locations where AV coat had shattered and ejected instead of burning away smoothly like it was supposed to. The Apollo heat shield had 320,000 individually filled honeycomb cells. Orion's design replaced all of that with roughly 180 large tiles. And under the heat of a real lunar return, those tiles trapped gas inside, pressure built up, and they cracked. Pieces of the thing that keeps astronauts alive flew off into the atmosphere. NASA spent 3 years investigating, they figured out what went wrong, and then they sent the crew anyway, on the same heat shield without replacing it. Their fix was to change the angle of re-entry, steeper descent, less time at peak heat, less gas buildup. Engineers ran over 100 tests at a facility in California to convince themselves this would work. Most of them agreed, not all of them. At the final flight readiness review in March 2026, some engineers voted no. They were overruled. A former astronaut and heat shield expert named Charles Camarda, a man who worked the Columbia disaster investigation and flew on the return to flight mission after it, publicly compared this decision to the thinking that killed the Challenger and Columbia crews. He called it institutional pressure overriding engineering reality. Independent analysts put the probability of heat shield failure somewhere between 1 in 5 and 1 in 50. That range is not reassuring. That range means nobody actually knows. The reason they didn't just replace the shield. It was already bolted on by the time they admitted the problem out loud. The crew is currently on their way home. The heat shield hasn't been tested yet. Number 2. The point of no return. About 25 hours after launch, Orion's main engine fired for 5 minutes and 55 seconds. That burn added 1,274 feet per second to the spacecraft's velocity, which doesn't sound like much until you realize that number is the difference between orbiting Earth and leaving it. After that burn, the mission committed. No turning around. No abort button. That means what you think it means. Here's how a free return trajectory actually works. The spacecraft isn't aiming for the moon exactly. It's aiming for a precise gravitational path where the combined pull of Earth and the moon will arc Orion around the far side of the moon and sling it back toward home, even if the engines never fire again. Gravity does the work. The crew is essentially a passenger on an orbital track they cannot get off. There is technically a direct abort option right after the burn, where you flip the spacecraft around, fire the engine the other way, and come home faster. But that window closes quickly. Get far enough toward the moon, and the math inverts. Completing the loop around the moon is now safer and faster than trying to brake and reverse. Past that point, the only way home is through. This is exactly what saved the Apollo 13 crew in April 1970. An oxygen tank exploded 56 hours after launch. The main engine was dead. The moon's gravity carried them around the far side and threw them back toward Earth, because the trajectory was designed to do exactly that in a disaster. The difference is, Apollo 13 had a lunar module attached, a separate spacecraft with its own engine and its own oxygen. The crew used it as a lifeboat for 4 days. Artemis II has no lunar module. If something goes critically wrong after the point of no return, the crew rides the trajectory home on whatever is still working and waits. There's also a 40-minute window when nobody on Earth can help them at all, because Orion passes behind the moon and every communication link goes dark. No voice, no data, no telemetry, just silence from mission control's perspective, and 4 people in a capsule on the other side of the moon, alone in a way no human being has been alone since 1972. Number 3, the life support has never actually worked. Orion has flown before. Once, with mannequins. The 2 test passengers on Artemis I were anatomically accurate torsos loaded with radiation sensors, wearing the same orange spacesuits the real crew is wearing now. They did not breathe. They did not produce carbon dioxide, body heat, moisture, or any of the biological outputs that 4 living humans generate constantly. The life support system on that flight was not fully installed because there was nothing alive to support. Artemis II is the first time Orion's life support has ever had to actually function. Commander Reed Wiseman described the first full day in orbit with unusual honesty. The crew spent 23 hours in high Earth orbit doing one thing, checking whether the spacecraft could keep them alive. Can it scrub the carbon dioxide out of the air? Can it regulate cabin pressure? Can the water dispenser work? Can the toilet function? These are not rhetorical questions. These are the literal checklist items from day 1 of a mission to the moon. Before launch, the batteries had to be completely rebuilt by the same company that saved the Apollo 13 crew because abort scenario testing revealed they might not hold power through an emergency. A carbon dioxide valve failed, seals on the environmental control system were found deformed and leaking, all of it was fixed, but fixed means replaced with new hardware that has also, by definition, never been tested in flight. And then, on day 2, mission specialist Christina Koch's personal computing device went dark before the translunar injection burn and never came back on. Mission Control tried multiple solutions. None worked. In a camper van the size of a small trailer, 4 people are living, sleeping, eating, and exercising, suspended in a vacuum 250,000 miles from the nearest anything. And the systems keeping them alive are, right now, passing their first real exam. Number 4, the price tag nobody says out loud. In 2012, NASA estimated each Artemis launch would cost around $500 million. That number turned out to be wrong by a factor of 8. The official figure from NASA's own Inspector General is $4.1 billion per launch. That number covers production and ground operations only. It does not include the decades of development costs that produced the rocket in the first place. When you fold those in, the total bill for the Artemis program through 2025 sits somewhere around $93 billion. The projection by the time of the first actual moon landing is $105 billion. The Space Launch System rocket, which provided the thrust to get Artemis II off the ground, took over 10 years to build, slipped its launch date 26 times, and was described in the current administration's own federal budget as grossly expensive and 140% over its original cost. That assessment did not come from critics or journalists. It came from the executive branch of the United States government that runs the program. For comparison, SpaceX's total estimated cost to develop Starship, a fully reusable rocket that can carry more mass to orbit, is somewhere between $2.5 and $5 billion total for the whole program. One Artemis launch costs more than that. Boeing, the prime contractor for the rocket's core stage, collected $234 million in performance award fees during the years the program was accumulating its worst delays and overruns. Cost-plus contracts mean the contractor gets paid regardless of whether the work goes well. NASA's own watchdog called the oversight sloppy and the payments questionable. Congress keeps funding it. And right now, $4 billion of aerospace hardware is currently somewhere between Earth and the Moon. Number 5. The race nobody admitted was a race. There is a reason this mission exists right now. In 2026, after years of delays, cost overruns, and a heat shield that broke and got flown anyway. The reason is China. China's crewed moon landing program is targeting 2030. NASA's first crewed lunar landing, Artemis IV, is targeting late 2028. That is a 2-year margin, which sounds comfortable until you remember that Artemis II was supposed to launch in 2024, then 2025, then February 2026, then it scrubbed in February, then it scrubbed again in March. It finally launched on April 1st, 2026. The program has been slipping. The margin is thinning. And the week before Artemis II launched, NASA canceled the Lunar Gateway, a planned space station in lunar orbit that was supposed to be a central hub for all future moon missions. The architecture that Artemis 3, 4, and 5 were designed around was scrapped. A new plan is being written, while the current mission is in flight. The original target under the first Trump administration was humans on the moon by 2024. It is 2026, and they have not landed. The first woman and a first person of color to land on the moon was supposed to be a headline of the Artemis program. That specific goal was quietly removed. What remains is a race. NASA just won't call it that. Number 6, the radiation shelter is a toilet corner. Once Orion passed through the Van Allen belts and left Earth's magnetic field behind, the crew entered an environment that has not had human beings in it for 54 years. And the reason it's been 54 years isn't nostalgia. It's because this place is genuinely hostile in a way that low Earth orbit never is. There are 3 different kinds of radiation trying to get into the crew right now. The first is the Van Allen belts themselves, 2 donut-shaped rings of trapped charged particles hugging Earth, which Orion punched through on the way out. The second is galactic cosmic rays, which are not from the sun but from dead stars. Supernovae, the violent ends of things that existed before our solar system did. These particles travel at near light speed. They don't bounce off metal, they go through it, and as they do, they shatter atoms inside the wall into secondary showers. Shielding makes it worse. The third is solar energetic particles from the sun, which are less predictable and potentially the most dangerous. The baseline radiation exposure for the full 10-day trip is roughly equivalent to a month on the International Space Station, about 5% of a career limit. That's the quiet background hum. The danger is the spike. In August 1972, between Apollo 16 and Apollo 17, the sun produced one of the largest solar particle events ever recorded. Any crew in deep space during that storm would have received potentially lethal radiation doses. The Apollo program survived that storm because no one was in deep space at the time. Pure timing, not design. Artemis II is flying near solar maximum, the peak of the sun's 11-year activity cycle. The warning system is real. Satellites across the solar system watch the sun continuously. Ground teams run forecasts. Sensors inside Orion trigger alarms if levels spike. But the emergency response, the actual shelter-in-place procedure if something bad happens, involves the crew moving stowage bags to specific parts of the capsule to put mass between themselves and the incoming particles. One NASA official described the best location to shelter as the storage bays and, quote, down by the toilet. Apollo astronauts reported seeing flashes of light with their eyes closed in deep space. Cosmic rays, moving through their retinas at near light speed. Most of those astronauts developed cataracts. Some developed cardiovascular issues. The sample size is 24 humans. We have been studying deep space radiation effects on the human body for 54 years using 24 people. Artemis II is doubling that data set in real time. And when the sun decided to stay quiet this week, that was luck, not a guarantee. Number 7. The distance record was set by a disaster. On April 6, 2026, sometime around 7 in the evening, Eastern Time, Artemis II broke the all-time human distance record. The crew traveled 252,757 miles from Earth. The previous record was 248,655 miles. It had stood since April 1970. It was set by Jim Lovell, Fred Hayes, and Jack Swigert on Apollo 13 while they were trying not to die. An oxygen tank had exploded 56 hours into their mission. The main engine was gone. The lunar landing was aborted. The crew was using the lunar module as a lifeboat, rationing power and water, breathing carbon dioxide scrubbing canisters MacGyvered into the wrong spacecraft while Mission Control in Houston ran manual calculations to keep them alive. They swung around the far side of the moon on a free return trajectory, and the distance they covered in survival mode became the record for the farthest a human being had ever traveled from Earth. That record stood for 56 years. Artemis II broke it on purpose, by design, intentionally retracing an emergency trajectory as a mission profile. The total trip distance from launch to splashdown is 695,081 miles. The ISS orbits 250 miles up. Artemis II traveled 1,000 times farther. The record was broken while the crew was behind the moon in a communications blackout, with no contact with Earth, waiting to see if the heat shield they couldn't replace would hold on the way home. Commander Wiseman had described what he saw earlier in the mission, looking back at Earth from deep space. Mission Control reoriented the spacecraft as the sun was setting behind the planet. He said the whole globe appeared pole to pole, Africa, Europe, the Northern Lights, if you looked carefully. All four of them stopped moving, just stared. That image, a marble in a black void, is what 56 years of distance records looks like from the other side. Number 8, 4 people in a camper van, 250,000 miles from home. Strip away the trajectory plots and the orbital mechanics, and what you have is this: 4 people. One space the size of a camper van. 10 days, no shower, no walking outside, no option to leave. The Orion capsule is 16.5 feet wide. 2 of the 4 crew seats are stowed during transit to create more floor space. Everyone sleeps at the same time, in sleeping bags attached to the walls, floating. The exercise equipment is a flywheel device smaller than a carry-on suitcase that maxes out at 400 pounds of resistance. Each crew member does 30 minutes a day. Not for fitness, because without it, the bones and muscles start to deteriorate in microgravity within days. Personal hygiene is no rinse shampoo and baby wipes. There is one toilet with a door. The toilet broke briefly during the mission in deep space. There are 4 windows. During the lunar flyby, the crew divided into pairs to take turns looking out, 55 to 85 minutes each, because all 4 couldn't observe at once. The most spectacular views any human has seen in over 50 years, and they had to take turns. And at some point on day 6, while they were passing behind the moon, the crew was the most isolated group of human beings in recorded history. Not metaphorically, literally. No Antarctic research station loses contact with Earth for 40 minutes at a stretch. No submarine, no remote outpost, nothing. The ISS is 250 miles up and has continuous communication. The Artemis II crew was 250,000 miles away with the moon between them and every other person alive, and for 40 minutes the universe was just the 4 of them and the dark. The toilet works again, by the way. Just wanted to close that loop. Number 9. The experiments nobody told you about. Officially, Artemis II is a test flight, systems validation, life support checkout, heat shield data. That's the public framing. But packed into this mission is some of the most ambitious human biology research in decades, and NASA has been pretty quiet about it. The Avatar experiment is the strangest one. Scientists built tiny organ-like devices from the actual cells of the Artemis II crew members, miniature replicas of their own organs, grown in a lab and loaded onto the spacecraft. Those organ chips are flying alongside the people they came from, experiencing the same radiation, the same microgravity, the same deep space environment. When the mission ends, researchers will compare what happened to the cells with what happened to the crew. It's the closest thing to a controlled experiment on human tissue in deep space that has ever been attempted. There's also a wristwatch-style device monitoring each astronaut's sleep patterns, activity levels, and well-being continuously. Blood and saliva samples are being taken throughout the mission to measure what deep space does to the immune system in real time. Not after the fact. During. 5 hours after launch, 4 shoebox-sized satellites from Germany, South Korea, Saudi Arabia, and Argentina deployed from the spacecraft and scattered into high Earth orbit. One of them contains material designed to mimic human tissue, measuring exactly what kind of radiation damage a body would absorb crossing the Van Allen belts. The data will inform every human mission that follows. And then there's the communications test. Orion is carrying a laser-based optical communications system, pushing data at 260 megabits per second between the spacecraft and Earth. That's the foundation for live high-definition video from the Moon and eventually Mars. Right now it looks like a technical benchmark. In 10 years it looks like the reason you could watch a live feed from the Martian surface. There is also, and this is real, active NASA-funded research into whether a plant supplement available at any pharmacy could protect astronauts from cosmic ray damage. Studies at a particle accelerator found it reduced radiation damage in human tissue at deep space dose levels. The crew didn't take it on this mission. But someone is trying to figure out if the answer to one of the hardest problems in space exploration is sitting on a shelf at your local health food store. The science at NASA talks about most on this mission is systems validation. The science that might matter most is what they're learning about what space does to a human body that no one else has been able to study for 54 years. Number 10. The history they rewrote without making a speech about it. Every single human being who has ever traveled to the moon was a white American man. All 24 who left Earth orbit during Apollo. All 12 who walked the surface. Everyone. That ended on April 1st, 2026 at 6:35 in the evening. Victor Glover is the first black astronaut to travel to the moon. Christina Koch is the first woman. Jeremy Hansen is the first Canadian and the first non-American in the history of human spaceflight to leave Earth orbit, all on the same mission. All quietly without a separate press release for each one, just as part of the crew of 4 people strapped to the most powerful rocket currently flying. The crew designed their mission patch to make the letters A and 2 look like the word all. Glover explained it as anti-division caulking, something to fill the cracks before they expand. They named the spacecraft Integrity. The zero-gravity indicator, the small floating toy that signals when weightlessness begins, was designed by an 8-year-old and depicts the moon wearing Earth as a baseball cap, a tribute to the Earthrise photograph from Apollo 8. After the translunar injection burn, after the engine fired and committed them to the moon, Jeremy Hansen said this: "Humanity has once again shown what we are capable of. And it's your hopes for the future that carry us now on this journey around the moon. The heat shield is still unproven. The cost is unsustainable. The race is real. The shelter is a toilet corner. And none of that changes what happened when that rocket cleared the tower. 4 people left Earth, farther than any humans in 54 years, in a spacecraft that might be fine, toward a moon that humanity has not touched since 1972. And the distance record they broke on the way was held by 3 men who survived an explosion by riding the same trajectory home. They launched on April Fool's Day. They're not joking.